Okay, now for our next phase in calculus, differentiation. Okay, now to do that, we can either determine the derivative from the first principles, or we can determine the derivative using the rules of differentiation. Okay, now that is big words that I just want to set aside for now. For now, we're going to focus on our gradient at a point. So in our previous videos, we talked about our average gradient, but now we're going to move to gradient at a specific point. In the previous ones, we talked about our gradient between this point and this point, or this point and this one, or this point and this one. And each time we worked with h, which is our difference between x2 and x1. Now, as we see, as we move this gradient, like we make this space between our first point and our second point closer to each other, our distance becomes smaller. Okay, h decreases. H moves closer to 0. So here I put it in a different way for you guys. So first we start with long distance, then a bit smaller, then a bit smaller, and as this goes smaller and smaller and smaller and smaller and smaller, firstly, this line is going to go up, 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 up. But h is going to tend towards 0. H is going closer and closer to 0. So here the distance was, let's say, 5, 4, 3, and then we come 2, and then it becomes 0. Where these 2 points meet each other, it then becomes 1 point, and the distance between these 2 points are 0. Okay, so now we say as we move closer to 1 point, h becomes less. H tends to 0. Now for this, to get a gradient at a point, we are going to use our knowledge of first limits. Like I said, h tends to 0. That should sound familiar. And of gradient, like our average gradient we just did now, but now we're going to add our knowledge of limits. Okay, we denote a derivative as this. Okay, the derivative of fx. Okay, so using all this information that we got, we are going to on to the next step. Okay, so the formula for gradient at a point, the derivative from first principles. Now I'm going to come back to this sentence, but whenever they ask you in a question, like use from first principles or show the derivative from the first principles, you're going to use this formula. Okay, this is the first principle formula. So the derivative of x is limit where h tends to 0, fx plus h minus fx over h. So now you can see, here is my knowledge of my limits and what to do and what's my next step. But this part comes from my knowledge from my average gradient. And to get my derivative or my gradient at a certain point, at one point, I need to merge this together. So that's a lot of words, but let's look at an example. Okay. Given the function fx, or 4x squared plus 8x. Okay, determine the derivative from the first principles. Again, I need to use my first principles. And I keep saying that as if there's another option. There is, but that is coming up a bit later. For now, we're looking at our first principles. So we're using this formula, and please write this formula so that you don't forget it. Again, I'm going to start with what I did in my previous one on my average gradient. I'm just going to substitute everything in here what I can. So firstly, I know that fx equals 4x squared plus 8x is my original one, the one I'm going to substitute in second. I'm not going to change anything. The thing where I need to change is where f, x plus h. So wherever I see x in my original one, I need to substitute x plus h. So now I'm going to have 4 bracket x plus h bracket squared. Okay, in our original one we just had 4x squared. Now we have 4x plus h squared plus 8. And in our original one it has an x, it's times by x. So now I'm going to have x plus h. Okay, now I'm just going to do the algebra thing, and I'm going to times these two brackets with each other, and I'm going to times the 8 with x and the 8 with h, and I'm going to end up with 4x squared plus 8xh plus 4h squared plus 8x plus 8h. Now, this is a lot of things, but I'm basically just going to substitute it back into that formula. So now I'm writing again, my derivative of fx equals my limit where h tends to 0. Now I substitute this whole piece in where I had in my formula f x plus h, and remember your negative because that is going to change your sign within the bracket. So I know a negative times a positive would give me a negative 4x squared, and a negative times a positive would give me a negative 8x. Now I'm going to cancel out. Well, not cancel out, it equals to 0. So 4x squared minus 4x squared gives me 0, which means I don't use it. Then I have here a plus 8x minus 8x. Again, it equals to 0. I take it out. Then I'm left with 8xh plus 4h squared plus 8h. Again, I need to factorize. I need to do something with these h's because it's too many. When I factorize it, I see there's a common factor of h. I take it out and I cancel it, top and bottom. Now, in my limits, I said as soon as you can, when it's possible, when nothing would, like if I substitute 0 in here, this whole thing would become undefined. Okay, but now that it cancelled out, it wouldn't be an undefined one if I substitute 0 in where h is. So in the previous ones, whatever h or x tends to, I substituted in. So for this one, h tends to 0. So wherever h is, I'm going to substitute 0 in, which means my derivative of x is 8x plus 4 times 0 plus 8, which leaves my derivative of x equals 8x plus 8. Now this answer is my gradient at any point of my equation. Okay, so I am simply going to end here because they ask me determine the derivative of fx. Okay, they ask me nothing more from the first principles. So now I'm at this point. Moving on, my next question, hence determine the derivative -4. And what does this answer mean? So now I'm going to use what I got my derivative of fx. Okay, I got as 8x plus 8. And whatever is in here, I substitute. Meaning I'm going to substitute -4 wherever I see x, which is 8 times -4 plus 8. At this point, -24 is my answer. So what does it mean? Where x equals to -4, like on that point on our graph, the gradient is -24. Now we can find the gradient at any point on the graph when I substitute that in. So where x is -4 on this graph, our gradient is -24. Now for my last question, what is the gradient of the graph where x equals to 4? So that means I'm going to substitute x with 4 into my derivative formula, saying it is 8 times 4 plus 8, and that would give me 40. Means at this point where x is equal to 4, my gradient would be 40. Okay, And that is how we get our gradients at a point. And that is also differentiation from our first principles. Again, that is the knowledge from our limits and from our average gradient. Now squeezed everything into one to give me my gradient at a point.